All right, section 3.5 notes, we are doing factoring by grouping. Okay, now when we got a factor problem, one of the main things we want to identify is which method of factoring do we have to use. And we had that on our last set of notes, which is right here, the 3.4 notes. First thing we said is, all right, if there's two terms, we're going to first look for a GCF, then see if it's difference of two squares, or maybe sum or difference of cubes. Okay, because if there's two terms and it's factorable, it's going to be one of these four things. If there's three terms and it's factorable, first we check for a GCF, and then we do our regular trinomial factoring. That can be with or without a leading coefficient. And then the nice thing about factoring by grouping is it's pretty easy to identify because anytime there's four terms, we're going to use factoring by grouping if it's factorable. Okay, and then we can also take out a GCF, but factoring by grouping is the only time that we want to take out a GCF at the end instead of the beginning. I'll show you why when we get to an example where that's possible to do. But first of all, here are our notes here. And let's dive right into example one. Now, example one doesn't have four terms. Normally when we're doing factoring by grouping, it's going to be a problem that looks like this, a four-term polynomial, like one of these three here. Okay, these are basically halfway done for us already. Okay, now factoring by grouping is not as hard as it sounds. All we're doing is taking out a GCF three different times. Now again, this first couple problems here, these first three, we're halfway through the problem already, so we don't have to do it three times. But that's all normal factoring by grouping is taking out a GCF three times. All right, so on example number one, it's not really factoring by grouping problem, but if we look at this binomial here, and it is a binomial, I've got this big term plus this big term. Okay, well, do those two terms have anything in common? Well, sure, they both have an x minus 2, so then that's the GCF. So think of it as, if I have this big, I'm going to use brackets so I don't have parentheses on top of parentheses. Okay, if I have that big binomial inside the brackets, well, what can I take out of the brackets? We can take out an x minus 2. And then if I take out an x minus 2, and it's okay to put brackets instead of parentheses. Okay, well, what's left inside the brackets? If I take out the x minus 2, I'm just left with the x here. And if I take out the x minus 2, I'm just left with the plus 3 there. And then so my answer is x minus 2 times x plus 3. Okay, and then we usually wouldn't have brackets there, so we'd write our answer like this, normally x minus 2 times x plus 3. Okay, but really it doesn't matter if there's parentheses or brackets, I was just trying to show it clearly. Okay, so if we get something like this, we're just looking at what do they have in common, and we want to take the thing they have in common outside. Okay, next, this one's a little bit different. We got a 4x times x cubed minus 2 minus 2 minus x cubed. Okay, now two things we want to do here. First of all, it just says minus that thing, or it might say just plus that thing. It might be easier to put a 1 in there. We want to think of that as minus 1 times that thing there. Okay, and then, well, I've got this big term and this big term. What do those two things have in common? Well, nothing. They almost have something in common. I got an x cubed here and negative x cubed here. I got a negative 2 here and a positive 2 here. So they're almost the same except for their signs. So if the only thing I want to change is the signs, then we want to take out a negative from one of our two binomials here. Okay, I don't want my x cubed to be negative there, so we want to take the negative out of this one here. So I'm going to leave this term the same. It's going to be 4x times x cubed minus 2. And then if I take out a negative here, I got to put that in front. Well, the negative times the negative is going to make that a positive. So if we take out a negative, it's going to change the sign. So now I've got positive 1 times, and if I take out a negative from each of these, it's going to change the sign and make it positive x cubed minus 2. Okay, so occasionally you're going to have to take out a negative before you do any other steps here. Okay, and then next, now what do these two big terms have in common? So again, I got this big term here and this big term here. Well, they both have an x cubed minus 2. So then I want to take out an x cubed minus 2. And then what's going to be left over? Well, if I take out the x cubed minus 2, I got a 4x left over here and a positive 1 left over here. And then that's done. Excuse me, that's it. I'm done factoring. Okay, now we do always want to check, can I factor this anymore and can I factor this anymore? But since these aren't factorable, then yeah, we're done. All right, next one here. Do these two terms have anything in common? Almost. This has x plus 2, this has 2 plus x. Do I need to take out a negative? Well, no, because these are both positive. I could just switch the order. So we could just write this as 5 times x plus 2, and then minus x times, and then I can switch the order there because they're both positive, x plus 2, because that's the same as 2 plus x. And then now what do they have in common? Well, now they both have the x plus 2 in common, so we can take that out. And if we take out the x plus 2's, what are we left with? 5 minus x, so then that's our other binomial. And then we're done factoring. Okay, now, one thing that you might want to do, it's kind of optional, but we don't like having our x values negative if that's the biggest power of x. So then we could factor out a negative out of here, and if we did that, we would take out a negative, so let's go this way where we have some space. Since I'm going to take out a negative, I'm going to put that in front, and then we still got the x plus 2. And if I take a negative out of here, now that's going to be positive x and minus 5. If it's written this way, it'll be a little bit easier to identify your x-intercepts. Okay, so kind of optional, but probably want to have it like that. All right, now let's move on to some problems where we actually have to factor by grouping. Now we got to do the whole problem. We'll zoom in a little bit so we can see these better. All right, so first of all, how do we know that we have to do factoring by grouping? Well, because we have 4 terms. So if it is factorable, it's going to be factoring by grouping. Now, like I said, factoring by grouping is just taking out a GCF 3 times. Okay, so the first time I want to do it is looking at these first 2 terms. What do those first 2 terms have in common? And then next, what do my second 2 terms have in common? And then once we take out a GCF out of here and a GCF out of here, we're going to end up with something that looks like one of these problems up here. And then we do it a third time, and then we're done. All right, so first of all, what do my first 2 terms have in common? So 6b to the third plus 8b to the second. Okay, well 6 and 8 both have a factor of 2, so I can take out a 2. And then they each have at least 2 b's, so I can take out b squared. So I can take out 2b squared, and if I take out 2b squared from these first 2 terms, what am I left with? Well, 3b plus 4. All right, and then next, what do 9b and positive 12 have in common? Now, one thing that you want to keep in the back of your mind is when you take out a GCF from the second binomial, what's left over should be the same as this thing here. Okay, so sometimes you want to take out a positive number, sometimes you want to take out a negative number. I don't want my signs to change because these are positive and these are positive, so then we want to take out a positive, what is the GCF? Well, 3. And if I take out a positive 3, what am I left with? 3b, and then plus 4. Okay, so those things match, which is good. That's what we wanted. So we took out a GCF once, we took out a GCF a second time. Now we want to take a GCF out a third time. What do these 2 big terms have in common? Well, they both have that 3b plus 4. So if I take out the 3b plus 4, and what's left over? 2b squared plus 3. And then I'm done. Now, if you're not sure if this works or not, multiply this back out, and we'll get that 4-term polynomial that we started with. Okay? In fact, let's do that one time just to show that this works. So a little scratch paper here. If we distribute the 3b, we get 6b to the third. And then 3b times 3 is plus 9b. I'm going to leave a gap here. 4 times 2b squared is 8b squared. And 4 times 3 is plus 12. So then we get this thing here. Is that the same as what we started with? Yeah, it is. Okay, now, sure, I left a gap here and kind of put things into different order, but even if I rearrange the order, it'd still be the same polynomial. Okay, so it does work. All right, moving on. Okay, next, so we got another 4-term polynomial, so how are we going to factor this? By grouping. So again, it's easy to identify. It's the only time we factor something with 4 terms. Okay, so first, I want to see what do my first 2 terms have in common. So 5y to the fourth and negative 15y to the third. I can take out a 5 or a negative 5, but we want to leave our biggest power of y positive, so we'll just take out a positive 5 and 3 y's, so 5y cubed. And if I take out a 5y cubed, I'm left with y minus, and then take out a 5y cubed there, we just get 3. Okay, and then next, let's see. I want my last term to be negative. That one is negative, so good. I want to take out a positive whatever they have in common, and then they each have a y, so I can take out a positive y, and then I'm left with y minus 3, which is good, so they do have something in common. Okay. Now, what do these two big terms have in common? What does that thing have in common with that thing there? Well, they both have the y minus 3, so I'm going to take out a y minus 3. And then I'm left with 5y cubed plus y. Now, when you're factoring, you always want to check and see, did I factor completely? Because did we factor by grouping? Yes, but is it completely factored? Well, not quite. We can't factor this anymore, but how can we factor this thing here? Well, this has another GCF of y, so I can take out a y, and then I still got the y minus 3. And if we take out the y from this term here, we get 5y squared plus 1. Okay. Now, in a couple more examples here, I'll show you why we took out the GCF at the end instead of the beginning. Okay, but factoring by grouping is pretty much the only factoring method where it's easier to take it out at the end. Okay, so just always check at the end to make sure you're completely factored. All right. A couple more on this page. Next, we got 2x cubed minus 12x squared plus 18 minus 3x. All right, so again, factoring by grouping, we want to take out a GCF from our first two terms to start. So here, we can take out a 2x squared, and that leaves me with x minus 6. Next, what are our second two terms, our last two terms, I mean, have in common? And we want to include that sign because we might need to change it. Okay? All right, let's see, what do I want to be left with? X minus 6. So I can take out a 3, and then I'll have negative x and positive 6, but then my signs would be wrong. Okay, so here we want to take out not just a 3, but a negative 3, because if we take out a negative 3, that's going to leave me with positive x, and it's going to leave me with negative 6. Okay, so try to be aware of your signs. That way you don't have to take an extra step and take out a negative by itself in a separate step. Okay, so we took out a GCF once, took out a GCF twice. Now we need to now we need to take out a GCF a third time. What do these two big terms have in common? The x minus 6. And then what's left over? 2x squared minus 3. Okay, and then we always want to check, is it factored completely? We can't factor that anymore. Can we factor that anymore? No, so we're done. Okay. All right, now we've got a few more examples, and now we're going to see how we factor these things and then actually graph them. Okay. All right, so example number 4, we want to factor this thing, sketch it, and then label the x and y intercepts. Well, since there's 4 terms, we know we need to factor by grouping. Now, let me get another piece of scratch paper and show you why we don't want to take out the GCF first. So don't write this part down. I'm doing this on scratch paper. If I take out a 2 first, which I can do, we get x cubed minus 5x squared minus x, and then plus 5. Okay? And then now I want to factor by grouping. So then I got to take a GCF out of here, which is going to be x squared. And then that leaves me with x minus 5. But then don't forget, we got the 2 on the outside. And then I got to take something out of here, which we just want to take out, well, just a negative to change the signs. And that leaves me with x minus 5. And then, well, there's just too many parentheses going on. There's just, we can do it, but it's kind of sloppy looking. Okay, so let's not mess with taking out the GCF in the beginning. Let's wait and take it out at the end so our problem looks a little bit cleaner. Okay, because yeah, we do have a GCF, but let's ignore it for now. We'll do that at the end. Okay, because otherwise, again, it just looks too messy. So let's just focus on our first two terms. What do they have in common? We can take out a 2 and an x squared, so 2x squared. And then that would leave me with x minus 5. And then what do our last two terms, including the sign, have in common? Well, I can take out either a 2 or a negative 2. Let's see, I want to end with a negative 5. I need to change that to negative, so I want to take out a negative number. So we're going to take out negative 2. And then that would leave me with positive x minus 5, which got these things to match, which is good. That's what we want. Okay, and then now, what do these two big terms have in common? The x minus 5. And then what's left over? 2x squared minus 2. Okay, so we did factor by grouping, and then now let's see if we can factor any more. Now can we take out a GCF? Sure, now we can take out that 2. I'm going to put that 2 in the front, and then we got the x minus 5, and that leaves us with x squared minus 1. Okay, now are we done factoring? No, because here, now we've got a difference of 2 squares. Okay, so then I got the 2, the x minus 5, and then I can factor this into x plus 1 times x minus 1. Okay, now I've got it completely factored. Okay, and now that we factored it, now we can graph this thing. Since I have a factor of x minus 5, I'm going to have an intercept at positive 5. So 1, 2, 3, 4, 5. Since we have a factor of x plus 1 over here, we're going to have an intercept at negative 1. And we got a factor of x minus 1, so we're going to have a intercept at positive 1. All right. And then next, to graph this, I either need an additional point or my end behavior. Okay, well, when you're given the polynomial in standard form, where it's all multiplied out, we get two things really easily. One, my end behavior is right there. It's odd and positive, so that's going to be low to high. Okay, or what's my y-intercept? Well, if I stick in x is 0, that goes away, that goes away, that goes away, and I get y equals 10. So then I could label my x-intercept, my y-intercept up here at 0, 10. And I can use either the end behavior or the y-intercept to draw my graph, because again, I know it's going to be low to high. I just got to know what happens at each of my intercepts. Well, since each of my factors had a multiplicity of 1, adjust the camera a little bit. They each had a multiplicity of 1. In other words, there's x minus 5 to the first, and x plus 1 to the first, and x minus 1 to the first. And it's going to pass through at each of my intercepts. So from my y-intercept, I know it's got to come down and hit this point. It's going to go through. It's also got to come down, hit this point, and go through, and come back up and hit that point and go through. So then, yeah, it fits my end behavior. I get a graph that looks something about like that. Okay, so it's low to high with a y-intercept at 0, 10, x-intercepts at negative 1, positive 1, and positive 5. Okay, there's only 2 more examples, so let's just keep this video going and do the last 2. All right, so example 5. Let's zoom out a little bit so we can see the whole problem. There we go. Okay, so 4 terms. So we want to factor by grouping. Yes, it does have a GCF of 3, but we'll take that out at the end. It'll be easier. Okay, so I just want to see, what do my first 2 terms have in common? Well, 3x squared. If I take out a 3x squared, I'm left with x plus 3. And then next, what do my last 2 terms have in common? Keeping in mind that I want to be left with an x plus 3, which means, well, I'm going to have to take out a negative number to make this a plus sign. So negative what? Well, what do those things have in common? Well, it's a big number, but 27 goes into both of those, which would leave me with x plus 3 left over, which is what we want. Okay. Now, if you don't take out the 27 right away, maybe you think, oh, 9 goes into both of those. That's true, but then these 2 binomials won't be matching. And then hopefully you realize after that, oh, I need to take out a bigger number. You can do that. So if you don't take out the biggest number right away, hopefully you'll catch your mistake. Okay. All right. So what do these 2 big terms have in common? Well, they both have an x plus 3, so we can take that out. And then what's left over? 3x squared minus 27. All right, don't forget we did have a GCF, so now we got to take that out. They still have that GCF of 3, so we can take out a 3. I've still got the x plus 3. And then now I'm left with x squared minus 9. All right, finally, are we done factoring? Not yet, because now what do we have here? Oh, now we've got a difference of 2 squares. So then the 3 stays the same, the x plus 3 stays the same. And then how can I factor x squared minus 9? Well, that's going to be x plus 3 times x minus 3. Now we're done factoring. Yeah, pretty much done factoring, but is this how we want our equation written? No, why not? Well, because I've got this thing twice. So instead of writing it twice, we want to write that with an exponent so that the multiplicity is obvious. So we have 3 times, let's just write this one next, x minus 3. And then what else did we have? X plus 3 twice. So we write it as x plus 3 quantity squared. Okay? All right, now we can start factoring this thing. Okay, so let's see. Our intercepts are going to be at positive 3 and negative 3. Where's our y-intercept going to be? Now, don't bother plugging in 0 and working it out. It's easier if you plug in 0 up here. If I plug in 0, that's gone, and that's gone. And I get my y-intercept is negative 81. So it's going to be down here somewhere. And as long as it's labeled correctly, then that's where it is. Okay. Next, we can either just go from this point and graph it, or we can use our end behavior. We wrote the end behavior last time. Let's just go from this point this time. I just need to know what happens at each of these intercepts, because I know from here it's got to come up and hit that one, and it's got to come up and hit that one. At my x-intercept of positive 3, here it's going to go through, so it's going to finish high. And at my intercept of negative 3, it's going to bounce because it has a multiplicity of 2. So let's see, low to high, does that sound right? Well, my exponent was odd for my, so it's a third degree, so yeah, that looks good. And then it's positive, so yeah, low to high fits my equation, so that looks good. Okay, so again, you can either use your end behavior, or another point on your graph to draw these things. Okay, last one. Let's wrap these up. Okay, so this time they want us to do f minus g of x, which is the same as f of x minus g of x. Well, f of x is this stuff here. So we got x cubed minus 3x squared. And then minus all of g of x. So don't forget to put it in parentheses because we will need to distribute this negative. Okay, and what is g of x? 4x minus 12. Okay, now first let's distribute that negative before we start factoring to get our actual four-term polynomial. So that's going to be x cubed minus 3x squared, and then minus 4x, and then minus negative 12, which is plus 12. Okay, so now we've got our four-term polynomial. Now we can factor by grouping. And this one, looking ahead, that's good. There's not going to be a GCF at the end, so we don't have to worry about that. All right, so what do my first two terms have in common? Well, they both have x squared in common. Also, just want to point out, if you ever think, well, they don't have anything in common, you can always take out a positive 1 or a negative 1 if you want to change the signs. So you can always at least take that out. If we take out x squared, we're left with x minus 3. And then what can I take out of here? Keep in mind, I want this thing to match this thing, so I need to change that sign from a positive to a negative. So then I want to take out a negative 4 is what they have in common. And then that would leave me with x minus 3. So good, they match. Okay. Now, what do these two big terms have in common? Well, they both have the x minus 3. And we're left with x squared minus 4. Okay. Like on a few of the other problems, we're not done because this is the difference of two squares. So then we're going to get x minus 3 times x plus 2 times x minus 2. Okay, so it's not just factoring by grouping. Sometimes we got to do other things as well. All right, now we can start graphing this thing. I've got intercepts at positive 3, negative 2, and positive 2. These each have a multiplicity of 1, so I know it's going to go through at each of these points. Let's see, since they asked us to label it anyways, let's get our y-intercept. If we look at our original big equation up here that we wrote out, if I stick in x as 0, I get y as 12. So I'm going to have an intercept somewhere up here at 0, 12. And then from here, I know it's got to come down and hit this intercept and go through. So it's going to start low. It's got to come down, hit this, go through, come back up, hit that, go through. So it's going to finish high. So my equation should support that it's low to high, and let's double check. My first term was 1x to the third, so it's odd and positive. So yeah, low to high looks good. And then that wraps up the notes.